Do you recognize this number, or maybe this art project? If you haven't, I suggest you go back to the Fibonacci Art Circle Collage video before continuing. The sequence 0, 1, 1, 2, 3, 5, and so on is a Fibonacci sequence, and as we know, each set of numbers like 1, 2, and 2, 3 have a ratio that's close to 1.618. And as I said in the Fibonacci Art Circle video, this number is the golden ratio. But how are the golden ratio and the Fibonacci sequence related? Let's try to figure this out visually by doing a small art project. You will need a piece of graph paper, a pencil, and some colored pencils or markers, whichever one you prefer. Take your piece of paper and draw a small square that has the side lengths of the first term of the Fibonacci sequence. Since the first official term is 0, we can't draw a square for that. As a result, we'll start off with a 1 by 1 square, since the first term is 1. Next, draw another square that shares a side with the first one and has side lengths of the second term, which for us is another 1. Keep doing this until you've gotten to the 9th or 10th term. Now, starting from the first square you drew, draw a diagonal across. Next, look at the corner of the next square and draw the next diagonal. We should start from the end of the first diagonal, like this. Try making your lines a little curved because remember we're making a spiral. And keep doing this until you've connected all the diagonals in the squares and created the spiral shape. Using your colored markers or pencils, make the spiral into any figure of your choice. You can do a bird whose beak is at the top of the spiral, or a cat who's curled up and whose head is near the end of the spiral. Or you could do something like me, and use the spiral to create a string of beautiful flowers. Guess what? The spiral that you created is essentially a visual representation of the golden ratio. And what did we use to draw the squares? That's right, the Fibonacci sequence. The ratio of the side lengths of the squares is roughly 1.68, as we saw in the Fibonacci Art Circle collage video. That's how these two concepts merged together to create the spiral. But what exactly is the golden ratio? It can be a complex idea, so let me draw it out for you. Say we have a line, like this, that is cut in half. The first half is A and the second half is B. And the proportion of A to B is 1 because they're halves, and halves are always equal. But what is the proportion of the entire line to part A? Well, A is half of A plus B, which is the entire line, and as a result, the proportion is 2 to 1. Okay, what about this line? This line is split into two parts as well. However, unlike the first one, you can tell that this line isn't split exactly down the middle. Instead, the first part, part A, is 1.618 times longer than part B. And what number is 1.618? You guessed it, the golden ratio. Keep in mind that just for our purposes, we are going to simplify the golden ratio to just 1.618, even though it has an infinite decimal representation. And something interesting about this line is that the proportion of the entire line compared to the length of part A is also 1.618. But you must not believe me, so let's test this out. Since A is 1.618 times longer than B, we can write it as 1.618b. So if A equals 1.618b and B stays as B, then the total length of the line, A plus B, would equal 1.618b plus B, right? And what does that equal to? 2.618b. That means that the proportion of A to B is 1.618b divided by B, which is 1.618, as we were given. And the proportion of A plus B to A is 2.618b to 1.618b, which is about 1.618, which is the same as the golden ratio. That's cool and all, but what does the golden ratio really do in real life? Well, the golden ratio ensures perfect proportion between numbers, objects, or parts, as we've seen. A over B is equal to A plus B over A if the proportion between the parts is 1.618. And the spiral of the golden ratio? Well, you can see it in more places than one. You know the Mona Lisa? And you ever wonder why the entire picture seems to be perfectly painted? You guessed it, the golden ratio. And the inside of a sunflower? The golden ratio. It can also be seen in the shell. Thank you so much for watching my video. I'll see you in the next one. Bye!